we started with this square, right? And we're actually going to do a bit more construction today. Not quite as detailed as last time with compasses and so on, but still. We started with the square, okay? And then remind me, walk me through. What did we do? What did we do first? We did a bisection, right? We did that, okay? So that we could put our compass along this line and then draw down an arc like so, okay? And the reason why that arc was really useful is because this exact length by Pythagoras makes this distance here the golden ratio. And that was kind of cool, right? You can check this length. We said that was 1, that's a half, and that's why that's root 5 on 2 in there. And then we extended it, and that, well, not that exactly, but whatever you've got in front of you, that's a golden rectangle, okay? It's a rectangle where its dimensions, its length and its width, or breadth, whichever you want to call it, they're in the golden ratio, 1 to 5, okay? And then here was our follow-up question. I said, have a look now at that, not just this big rectangle, but look at the little rectangle that you added onto the square, okay? So we had a look at this distance here, okay? And we calculated, what was it? This is the last thing we kind of ended on. Anyone got that distance there? Yeah, Eric.
Root 5 minus 1 and 2.
Good. Okay, and you look at that, and we get that simply from the fact that that there is root 5 on 2. You subtract a half, and that's what you're left with. Okay. So here's where I'm going to take you, and I wonder if in a second, when the 3 or 4 of you who did have a look at it, we'll see if you got this same result as well. Have a look at this new rectangle with me. This is the ratio of its sides, right? Just like I've got this ratio here, I've now got this ratio here, okay? But have a look at it and think back to what you know about surds, because surds are notoriously difficult to work with, but they're not impossible, okay? So when I look at this, right, I want to work with this, I need to get rid of those surds. What would you suggest I do to this? This is a ratio. What should I do to both sides in order to get rid of that surd? Any suggestions? Yeah, Eric, do you want to give us a...
Multiply them by 2 and square them.
Okay, I'm going to have to multiply here, right? Now, you guys know the reason why we multiply, and this is what we're going to do, is called rationalizing, right? Is because surds are notoriously antisocial creatures, right? They don't mix with anything, okay? You can put a whole bunch of these together, and there's nothing you can do to simplify it. They don't like terms. They're all like, yeah, no, I don't like those other guys, we don't mix, we just stay apart, okay? So in order to get around that, we multiply. Now what I'm going to multiply by is this. It's a special term. This guy here, okay, root 5 plus 1. It has a special name, starts with a C. Does anyone know what it is? It's called, I think I heard it, it's called the conjugate. Which is worth writing down if you didn't know what that was called, okay? Which just basically means the other half of like a matching pair. Can you see these two guys are kind of like two sides of the same coin? There's a plus 1 and a minus 1. Okay, we see these all the time. So being that I multiply the left-hand side of the ratio by this number, by this conjugate, you can't just multiply things on two sides of an equation or ratio and have it different. Okay, so we want to maintain the same thing on both sides. I have 1 here, so when I multiply by root 5 plus 1, I just get root 5 plus 1. So far, so good? Yeah, cool. Now, why is it important, or why is it useful to multiply by the conjugate? It's not random. Why is that actually helpful to us? Yeah, Kevin.
Because you can get rid of the, you just go just root 5 squared and then minus 1.
Yeah, fantastic. So what I've got here is really the factorization of difference of squares. We recognize this, right? This is a minus b, a plus b. That's a squared minus b squared. Look, see, 2 squares, and we're getting the difference. Yes? Okay. So therefore here, we'll write it out in long form. This is a squared minus b squared, right? Which of course is not very hard to work out. It's all over 2. And just for the sake of it, I'm going to reverse the order of my sum over there because it doesn't matter. Okay? Okay, now we can evaluate this. In fact, you probably could have evaluated it here without doing that extra step. This is going to be 5 minus 1, which of course is equal to 4. 4 divided by 2, which is equal to 2. Right? Hold on, one more step. Look, if I divide both sides by 2 to make this 1, because we like having 1s as one of our ratios, I've got 1, 2 Well, I divide both sides by 2, right? Hold on. What just happened? What is this number? This is fine. This is the golden ratio. So what just happened? I was doing this, I was walking you through this whole construction in order to create a golden rectangle, this big shape here. But in fact, you made 2 golden rectangles, right? In fact, the golden rectangle always creates another golden rectangle within it, alongside a square, okay? So this golden rectangle, it has this kind of self-similar property to it, right? And that's what we're going to take advantage of today.